Hello everyone, my name is Tahmine and this video is about machine learning. In this video, I will speak about what is machine learning and what is its application, for example, and how many different models we have in machine learning. And I will explain a simple example, regression of machine learning models. What is exactly machine learning? Machine learning is a subfield in artificial intelligence, and it is about the capability of machine to imitate humans' behavior. For example, recognizing pictures, be able to classify different pictures. For example, pictures of humans, animals, and or different animals or the ability to recognize different handwriting and to be able to read the alphabet, recognize the alphabet in different handwriting. Um, there are lots of examples of machine learning, and we are using machine learning in all day. For example, I have here different example of using machine learning chatbots and predictive text when we write something and it is corrected automatically. It is a use of machine learning or language translation apps. I think all people now in the world uses translation apps, and it is a normal use of machine learning. Or when in Netflix or other apps or websites, some videos are suggested to us. It is also machine learning based on what we watched before. Or for example, in social media, when in our exported different videos are suggested to us, it is also a use of machine learning. Or autonomous vehicles, it is also machine learning, and machine learning is really helpful in other science. In medicine, for example, it can make possible to diagnose a medical condition based on a picture or image of a patient. And I have here a definition of different models in machine learning. We have basically three different models in machine learning: supervised, unsupervised, and reinforcement machine learning models. What is exactly supervised machine learning models? In this version of machine learning models, we have labeled input. It means that for every space and for all single input is defined which output we will have. And in the training process, we should give this data to machine to train the machine and prepare it to make prediction. And for example, when in our email, machine is able to recognize spam email based on some features or definition. And another model is unsupervised machine learning model. In unsupervised machine learning model, we only give input to our machine in training process, and machine should find a pattern by itself by trying to find a pattern. For example, when we give the machine different photos of dogs and cats, and the machine should find similarities and differences between these pictures and put them in different categories based on their similarities. And after finishing training process, when I give the machine a new picture, it should be able to recognize to which group belongs our new data, and it is unsupervised machine learning model. Another example is another kind of machine learning model is reinforcement, and this one I think it is really interesting because and the idea behind this machine learning model is based on maximizing reward. The machine should choose the acts which will maximize the gaining rewards, and it is helpful and useful for example, in self-driving cars. Yes, that was about different machine learning models, and that was too brief, but I think it is enough for now about machine learning and its definition. And now about a regression model. Regression model is a um, simple problem that we can use by using machine learning. And the algorithm is designed to find a relationship between independent and dependent variable. Independent variable is our input x and dependent variable is our output y. And we should find a function or line which can describe the relationship between inputs outputs um, by minimizing error. And regression has lots of application in the world. And for example, in sales environment, we can predict say next month's sales based on our current information or something like that for next season, next year based on our at hand information. And we have different type of regression, single linear regression, polynomial regression, support vector regression, decision tree regression, and random forest. In the next slides, I will explain about simple linear regression. When we have only one dimension for our input and output, linear regression will have the simple form of y is equal to beta 0 plus beta 1 x plus epsilon. And beta 0 is the amount of our dependent variable when is equal to 0. And beta 1 is a regression coefficient which can explain which correlation between x and y should we expect, or there is which correlation they two have together. And epsilon is our error, and as I said, x is input independent variable and y is output our dependent variable. Simply, it looks like this, and these blue points are our true data point. With them, we want to try our machine, and this red line is our regression, what we predicted about a relationship between output and input and output. Now, if we have n dimension, um, we should define objective function for our problem, since it's an optimization problem, and the objective function is like that, and it is the difference between our predicted value and real value, and this predicted value is equal to this equation, and this is actually error, and we want to minimize our error. And m is size of our data set, our training set actually. Now we want to find theta 0 to theta n, which will create or define our prediction. Uh, at first step, we should start with an initial value. We choose as random some value for theta 0 to theta n. And now we need to calculate gradient. And gradient is a derivative of function j for each theta 0 to theta 1. This derivative at theta 0 can be calculated with this relationship, and for theta 1 is calculated with this relationship. And for each theta j equal to 1 to n can be calculated with this equation. In the other words, we can define gradient with this equation, since h is our prediction and is equal to this equation. Now we want to update our initial value, and we should update this value with alpha, which is our learning rate. Learning rate tells us with which speed we should move in direction of gradient, and it is important to have or choose optimal value for alpha. Alpha is hyperparameter hyperparameter, and its value should be um, defined or calculated before starting training process. And I have another video about hyperparameter optimization, and it is too important to have the optimal value for our hyperparameter optimization and learning rate, because with optimal value we will have better model and we can solve this model easier, and if we start with bad value for our hyperparameter, it is possible that we stuck from our optimal value and never find that. So we should repeat step 2 and 3 until our error is minimum, and we can find optimal value for optimal prediction, or optimal line for our training dataset. Now I have here a little bit better explain which effect has alpha on our prediction. When we try to optimize our algorithm with a small learning rate, it seems like that we start from here and our steps are really small, and it will take too long to reach this line, and it is possible that we never reach this line because the iteration will be too much, or time is out, or we're stuck in a local optimal area. And if we start our optimization process or solving algorithm with optimal value for learning rate, it is look like this one, and we have reasonable steps here, and we can meet our optimal line also easily. Now when we have here large learning rate, it is look like this one. Our steps are too huge, and it is possible that we jump from our optimal value, and so it is important to have optimal value for learning rate, and in each machine learning model choosing optimal value for hyperparameter optimization in order to have better model to work on. And yes, that was briefly about machine learning, its definition, and a really simple example of machine learning. If you are interested in my videos or find this video helpful, please subscribe to my channel and like this video, and write a comment and suggest what do you want to learn about machine learning. Thank you. Bye.